For the activity debugging list remove second last. So at the top here we have our starter code like usual, followed by the debugging tips. If you haven't already, I recommend you have a read of the Comp 1511 debugging guide. And now we have the task. So this task takes in a linked list via command line arguments. Then it attempts to remove the second last element of the list previously created via the delete second last function. For example, if the existing list is 1, which points to 2, 3, 4, and then null, after calling the delete second last function on the list is as follows: 1, 2, 4, and x. Note that the node containing the value 3, which is this node here, was removed from the list since it is the second last element. So 4 is the last because that's the one that points at null. Currently it has some issues. It's our job to figure them out and fix the code. And here we have the expected behavior. We have an assumption, so we may assume that all command line arguments will be integers. And here we have our style and auto test commands. So I've got the starter code here. Let's compile it and see if there's any immediate issues. Okay, so it seems to compile correctly. So let's see what happens when I try run the program. So let's just go 1, 2, 3, and 4. Okay, so the program crashes and doesn't quite work as expected. And we get the error malloc use after free. So access to memory that has already been freed. And we can see that we call free on current next, and then we try assign current next. So that's going to cause some issues. So let's just, I guess, swap these lines and see if that fixes the issue. Okay, so we can see that something's happening, but we're just removing the last node in our list, which is not quite what we want. And if we have a think, if we're going current next equals to something and then we're freeing current next, that's going to cause some issues and not be quite what we want. So what we should be doing is creating a temporary pointer. So struct node temp equals to current next, which when I exit this loop, it would be like, for example, at the node 2, where current next being the node 3 is the one we want to remove. So what we could then do is we know current next equals to current next next, and we want to free temp. So let's see if this fixes it up. Okay, we can see that it's still always just removing the last node in our list. So let's have a look at what's going on in our code with a diagram. So if we have 1, actually let's make this a bit bigger. 1, which points to 2, which points to 3, which points to 4, which points to null. Okay, so we check. If head equals to null, head is this one. So this is our head pointer. And we'll do our current pointer as well. So this is current. It's going to be green. Okay, so head equals to null. Nope. And list length. Our list is not the length of 1. We go here. Struct node current equals to head. While current next next does not equal to null. So current next next does not equal to null. So we move current along. So this node gets moved along. And now we check. Current next next, that does not equal to null. It's true, so we move the current pointer along. While current next next does not equal to null, in this case it does equal to null, so we go struct node temp equals to current next. So this one here is going to be our temporary pointer. Current next equals to current next next. So current next equals to current next next, which means that this connection is lost. And then we free the temporary node. So this is what's happening, and we can see it's not quite removing the node that we want. We want to be stopping 1 before 3 because that's the one we want to be removing. So realistically, what we want to be happening is we want current to instead be stopping here, so that this node becomes our temp and this becomes the connection, right? So if we want this and we want the second last, it's current next next next. So we can add another next in here and we'll see if that fixes it up. cool. So that removed 5, which is what we wanted. Let's try with a slightly smaller list. That removed 3, as expected. So now if we keep getting smaller, that removed 2, as we wanted. And then we got a little bit of an issue, because when our linked list is just 1 and 2, which points to null, it will look something like this. And current points to head right now. And the first thing we check is current next, 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 which doesn't exist and exceeds the length of our list. So what we can do is we can do a check for if the length of the list equals to 2, because we don't have that next, next, next happening. So we can recompile it and we can check that it still works with this small list. Yep. Oh, shouldn't have been removing both nodes. What we need to be doing is we need to go struct node new head equals to head next, and then we want to free head and return our new head. So if the list is 1, this is just going to be null, but if there is another node, it'll bring that back to us. There we go. So it works with 1 node, 2, 3, works with 3, 4, seems to be working as expected. So let's run auto test on this. Ooh. Something is not as we expect with the auto tests for it to be printing. Think we want to be printing some words. As we look at the spec on the right on ed, we want to be doing this. Print f original list, and then we also want to print modified list. This should fix it up, I think. Yeah, cool. Oh, we failed one. What's going on? So this is the case when there is no nodes in the list. So what we want to do is we want to do this. What we can do is we can do this check separately. Because of that, we just want to return null. Okay. See if this fixes it up. And that's working. So this is the final solution for the list delete second last debugging question.